DC converters that are out there. That one and the center tap one. So the only difference is that this one takes up, uses up twice as many diodes and stuff.
Which one is better though?
It depends on your application. The other one is good for, the one is, since you're only dropping across one diode. Well, here I'll kind of tell you. This one here we're going to be dropping across two diodes,
yeah.
So we lose some of our voltage across the diodes.
You have a higher DC average.
But we did end up with a higher DC average, where the other one has a lower DC average. But the other one is good for higher currents, because then if we're going to make like a transformer. But here, let's go through this one first, and then let's come back to Bob's question there. Then we can see how this one works first, so we understand the difference between the two. All right, so 20 volts AC. Am I using the center tap on this one?
No.
No, that's just not. So we don't even have to worry about it. So again, we always analyze that first half, that signal, so we know that my 117 volt AC is going to go positive. So I know that my clarity across my transformer is going to be negative positive. That's going to be my clarity across my secondary for the first alteration. Just on a quick note here too, you do need to be a little careful when you're doing transformers. I don't know if you can remember your readings from chapter 14, but when you're looking at transformers, we have phase indicators. So, for example, we're assuming that the phase indicators are that way. Okay. If the dots on the transformers, the dot on the primary was up here, and then the dot on the secondary was down here, that would indicate that they're 180 degrees out of phase. So that means, and what I mean by that is, right now we're assuming that they're in phase, so that means if this signal goes up for the first alteration, the output of the secondary is going to go up. If I had the phases inverted, then what that means is that if this one goes up, this one's actually going down. The phase is it's inverted. So if it was inverted, then my polarity across it would be this way for the first alteration. So a lot of times we just make the assumption that it's in phase. Just a little thing that I removed about in chapter 14 that you kind of be aware of out there in the industry. All right, so we're doing our first alteration. There's the polarity across my secondary. What's my voltage peak going to be for my secondary? 28.28 volts peak. Okay. Then we circle all our active components. Get the polarities in there. Okay, and then analyze our circuit here. So I put my, so here's my ground. We're going to treat all my diodes as an open. So here's my ground, and then this is going to be my source. So if I put my black lead on the ground here, it would be the easiest way. So we're going to do diode number 1. So let's bring it up here. So here's my, let's see here, I was going to, this one's always on, I'm going to try, this one's difficult because of, here I'll show you why this one this was a difficult one to really actually comprehend, is because I have, if I treated all these diodes as an open, this diode is an open, all these are open, so I really don't even realistically have any voltage going to any of those things. If I ideally, you know, I would treat this as 0, and this one as a 0, because I'm really kind of, there's nothing really actually hooked up to the circuit. So when you first are analyzing these ones, it's a little bit more difficult to see what that voltage actually is. What would you actually end up measuring across here? But assume that it's going to be your source voltage of your secondaries of your power supply. So we know that, so across here, so from referencing it to ground to here, what would I measure for my soft voltage on D1? Yeah, my positive 28.28 volts DC. Or not DC, but voltage peak, sorry. That's going to be my soft voltage on that side. And then since the other one is just tied to ground, we obviously know what that one's going to be, so what would be my soft voltage on my anode side? Yeah, plus or minus 0. So is that diode going to be a go or no go? No. That one's going to be a no go. So we know there isn't any current flowing through there. So then we want to analyze number 2. So referencing to ground, what would I end up with the soft voltage on this side?
28.
Yeah. So my positive 28.28 volts peak. And then on my cathode side?
Plus or minus 0.
Plus or minus 0. So now is that diode a go or no go?
Go.
That one's a go. And it's going to drop this 0.7 volts. And the current going through the diode is going to be going from right to left. So we already know that our current going through the diode is going right to left. Alright, then we're going to take a look at diode number 3. And on diode number 3, what would I end up with a soft voltage on the anode side?
Plus or minus 0.
So here's my ground.
Plus or minus 0.
Yeah, plus or minus 0, because it's tied right to ground. So we know that one's ground. And then I always said that this one here on this side is going to be my source voltage. And and so I'm going to get a negative. Okay, so is that diode going to be a go or no go?
Go.
That one's a go. And it's going to drop this 0.7 volts. Okay? And then we're going to analyze diode number 4. So on this side of my diode, what am I going to measure for voltage? Plus or minus 0. And then on this side, I'm going to measure what? Right. Okay, so is that diode a go or no go?
No go.
That one's a no go. And it's going to drop the source voltage of that 28.28 volts peak. All right, so now we determined that diodes 1 and 4 are off, and diodes 2 and 3 are turned on. And we know that the current going through diode 3 must be going this way then. Once we determine that it's a go, then we know the current going through that way is a go. So if we look at it from my source, then here's my source. This is more negative, so I know that my current is coming out of my, right here so you can see the current path. So my current is coming out of here, it's coming in, it's going to come into my first current node. Is any of the current going to go off to the right?
No.
No, because that diode isn't open, so that's not even part of the circuit. But then it goes up into this diode, through this diode, up into our next current node. Any current going to go that way? No, because that diode isn't open. Even though we'd like to try going that way, because that's the closest way to get into the positive side of the source, they can't because that diode is treating as a switch and it's preventing it from doing that. So then the only place it can go is going down through the ground. So it comes down through the ground, up to the ground, up from the ground, then across our load, then back into our next current node. We already determined that there's no current flowing through this way, so then the only place it can go is this way, through the diode, up to the diode, and now it's trying to seek positive side of the source. So that's our first current path. So it's coming out of our source, going through D3, through the ground, out of the ground, through the load, up through D2, and then back up into my source. So it appears to the circuit that these two diodes aren't even in there. Okay? So those first two diodes aren't even in there. Alright, so now we have to determine what my voltage out is going to look like. I already got the polarity across my load, so I know that my polarity on my output is going to go positive. And I'm going to warn you right now to be careful, because on one of your quizzes, midterm, or final, that those diodes are going to be flipped around. And if I flip those diodes around, what do you think my output's going to do? Change, and it's going to go negative. So if you're not paying attention and putting in your, circling your active components and stuff like that, and watch your directions of your current, we're going to do so many that are always positive, that when that one that comes negative comes about, you're going to miss it. So watch your current of your going through your diodes, and then watch the current going through your resistor. Don't always assume that they're always positive, because we can have positive and negative voltages. So we know that this one is going to go positive, and how far positive is it going to go? So we know that my source voltage going into my bridge rectifier is 28.28 volts peak, right?
27.58.
No, I think it might have jumped another 0.7.
And we went through how many diodes?
2.
2. So how much voltage is going to be taken up by just the diodes itself?
1.4 volts.
1.4 volts. Alright, because we went through 2 diodes. The diodes always take their voltage first, no matter how many are in there. And then the remainder then is going to be coming out of our voltage off peak. So then what do I end up for my voltage off peak then?
26.88
Volts.
volts peak. Volt, yeah, positive.
Yeah, volts peak, yeah.
So positive 26 point what?
88.
88 volts peak. Okay? So that's how tall it is. Okay? So that's your first alteration then.
Bless you.
Alright. So our next alteration, I'm gonna erase this, but then I'm gonna put that first alteration of that current path in there. I'll keep that as red. So I know it's coming out of here, going down through my ground, up to here. So that's what the first alteration looks like. So we'll keep that as red, so then we can compare it with the next alteration. All right. So now the next alteration is going to go negative. So the polarities across my transformer are going to change. So we'll analyze D1. So now what am I going to get for voltage on the side of D1 here?
Negative.
Yeah, negative, and it's going to be the negative what?
28.28 volts.
Yeah, the negative 28.28 volts. And then on the anode side, it's going to be what for voltage? That one's very tight to ground, so what's that voltage?
0.
Yeah, plus or minus 0. Okay, so now, does that diode go or no go?
Go.
Yeah, it's a go. It's a go, and we always give it voltage first. And we know that this is more negative than this. And we know that the current is going to the diode that way. Alright, now we look at diode number 2. So we're going to be at a negative 28.28 volts here. What's my voltage on my cathode side? Plus or minus 0. Go or no go?
No go.
No go. And it's just going to drop its source. Alright. So diode number 3 then. On my anode side, what's my voltage on my anode side? Yeah, plus or minus 0. And on my cathode side? Yeah, it's going to be positive this time. So this time it's going to be a positive 28.28 volts. Alright. So is that diode go or no go?
No go.
That's a no go. Okay, then diode number 4. And obviously, you know, that one's probably going to be a go. We know that this is going to be plus or minus 0. And then on my anode side, it's going to be the same. It's whatever this is here on it, so it's going to be a positive 28.28 volts peak. And we already determined that it is a go, and it's going to drop at 27 volts. And the current going through that diode is going to be going from right to left. Okay? So now we know that, so we figured out which ones are go and no go. We know that my current now, coming out of my transformer, is going to be just the opposite. It's going to come into our first current node. It's going to want to go to the left or to the right?
To the left.
To the left. So now this time it's going to go through diode number 1. Go through diode number 1, come into our ground. We know this is an open, so the only other choice it can go is down through our ground. Out of our ground, back up into our ground. And then this time it's comes into this current node. We know it's not going to want to go this way because that's a no-go. It's going to come through this diode here. Out of this diode, not going to want to go that way because that's a no-go, so it's going to want to go back to the source. Now all it's really doing is every time this thing switches alterations, basically it's flopping between D2 and D3 and then D1 and D4, and it's just kind of sitting there, and those are turning on and off 60 times a second. And those two diodes are just kind of switching back and forth. And then so then it ends up giving us the same polarity across our load. So knowing that, then my load is going to be more positive than my ground is, and so I know that my second alteration is going to go up. And it's going to go up to, again, it's going through 2 diodes. Here's my source voltage. It's going through 2 diodes. Then it's going to drop down to 26.88 volts peak. So here's my first alteration, and then my second alteration. So now you can see I doubled in my voltage there. All right, so then again now then once we figure out that what our voltage off peak is going to be, then what's my DC average going to be going across my load resistor? So 17.12 volts DC. What's my current going to be? Yeah, 17.12 milliamps. And my power going across that resistor then, how much power do I have going across that resistor now?
300 and something.
How much?
293.1.
293.1 milliwatts. Okay, so you can see that our DC average had doubled compared to the other one with the center tap. If that doubled, so did our current. Does our power double?
No.
No, that doesn't double. That's exponentially grows. So, yep. So watch out. Your power doesn't double. All right. So this is what you get with this. And what's our frequency ripple on this one?
120.
120 again. So here's my input signal, and then my output signal is going to just. There's both of them have two waveforms, two complete waveforms. This is just twice as much as this one, so it's going to be 120 hertz for our frequency ripple. Okay. All right. So then, so that very first circuit that we had, very seldom will you ever see that circuit. Once in a while, we'll see that half-wave rectifier used in battery supplies for our power battery chargers and stuff like that. But typically, you'll see either the second one or this one here. Now, the only difference is that now this one here, if we need to get more voltage out of, we're all three of those circuits are all using the same transformer. This here voltage gave me more voltage, more current, and then that previous circuit gave me half the voltage and half the current. Now, the benefits of this one here, this one's good for higher voltages, but a little bit lower current. Not that I couldn't handle the current, but if I needed a circuit that drew a lot of current, I'd have to go with some pretty big diodes. So if I wanted to go with some really large diodes, I'd have to buy 4 of them for this particular circuit to handle all that current. And then once we start getting up into the diodes that can handle the higher current, they get to be very spendy. Okay, so now if you're making a production run of these things, you might not want to put in 4 expensive diodes into a circuit. So if I go back to the other one, two is cheaper. I like that AT&T commercial. It's not that difficult. So here, I get half the voltage, but I can go ahead and draw a lot more current than only using the 2 diodes. So depending on what my load is, I'm only paying for 2 diodes, so half the cost for my diodes for drawing larger current. So that's kind of the benefits of one or the other. That this one's good for high current applications, lower voltage. And typically, what a lot of times you'll find too is that a lot of times when you're working with devices that are very high current, especially in the DC stuff, is that typically it's low voltage. It's low voltage but high current. It's very low output peaks and stuff like that. So that's kind of the benefit between the two. For most of our circuits, our electronic circuits, low current applications, our 24-volt power supplies and stuff like that, if it's not a battery charger or anything that needs a lot of current, typically you'll see this circuit. This is probably the most common circuit. So the bridge rectifier is the most common, and then the center tap is the next one, especially for like battery chargers and stuff like that. So, all right. So you'll get a lot more practice because we're going to be repeating this all over the first part of the. So tomorrow when we go over the other rectified circuits, they're going to be the same circuits. The only difference is that this time we're going to do filtering. We want to get a nice clean DC. So we'll get some more practice doing those circuits there. All right, if anyone didn't have any questions, then we'll continue on tomorrow. And then don't forget about the diode test on Friday. So.